that sarcasm?
Good morning, ladies and gentlemen. Take out your computers. Get logged in. Take out your periodic tables from yesterday and start thinking about the question of the day. You are going to have to name me a metal or a non-metal and tell me what its charge would be when it becomes a stable ion, ladies and gentlemen. Let's go, let's go, let's go.
My mom says that's a stable I had the worst dinner last night. I had a double plate. No, it's actually a triple plate. It was originally a double plate with extra mayonnaise, extra tartar sauce, extra cheese, extra fish patty, and like extra everything. And 4 tables. And extra onions both. It was not. Yes. All the food there is really well. I don't really care for this.
I can spend the day, it's not that bad.
No, just like the side of the road.
Today and advice.
The leftovers.
16.
SurveyMonkey.com.
All right. Declan, get us started.
Nice. Oh. Name a metal or non-metal on the periodic table. Lithium is metal.
Okay, tell me its charge when it becomes a stable ion.
1.
What kind of one? There's 2 ones. There's positive 1 and there's negative 1. 1 is not a charge. 1 is a number. Positive 1. Yes. Good. Good. Jaden. One is a number. Give me a charge, please. Positive 1. Good. Anthony. We got your periodic table from yesterday. All the charges are written on it. So give me any metal. You could also look up there and then look above or below the family or the group and find the answer as well. So go ahead, find your periodic table. We'll wait. Nitrogen is a -3. Very good. Good. Keanu, give me one while I'm getting your paper out here. All right. Make sure you get this into your notes then. Jasmine, go ahead. Charge is a -4. Very good. Annie, go ahead. Wait, that was what she just said. Give me a different one. Don't steal Jasmine. She did hers fine. Phosphorus is a -3. Caden, go ahead.
Lithium is.
What's that?
Sodium is +3.
Sodium is a what?
+3.
No, not a +3. Look down at the bottom of the family. Look down at the very bottom where sodium is. Do you see at the very bottom there, up on the periodic table, a number that is written there, a positive or a negative number?
-3.
Oh, sodium is right here, right?
Yeah.
Okay, so up there, go down to the bottom. What number is written below francium?
positive.
Positive 1. Very good. Very good. Very good. All right. Isaiah, give me one.
Radio has +2 charge.
Positive 2 charge. Good. Morgan, give me one.
Arsenic is in there.
Arsenic is a -3. Very good, ladies and gentlemen. Miss Rose.
Also, I bet you didn't wish your happy feelings a happy birthday. She needs the other hand.
Rose, do you get your periodic table from yesterday? Okay. Pick an element on the periodic table not in 3 through 12, Rose. Any element. Anyone. Pick an element on the periodic table not in this area 3 through 12 and not down here. Any element you want. Which one? Okay. Okay. Now go down to the bottom and tell me what its charge is. There you go. +1. Okay. Joshua. Silver is also a +1. That was one that I gave you yesterday, ladies and gentlemen. Silver is also a +1. That one I had you write it by the symbol. All right. Michaela, give me one. Neon, ladies and gentlemen, neon is a 0 charge. Okay. Neon is a 0 charge. Hey, Pete.
Magnesium's +2.
Magnesium is a +2. Okay, magnesium is a +2. Okay, so ladies and gentlemen, if you do not have this down in your notes, you need to get this onto your periodic table, ladies and gentlemen. By the way, I will always have this periodic table up here at the front of the class. So if you ever need to copy something that is on mine that is not on yours, all you need to do is let me know, ladies and gentlemen, and I will put it out there for you. But these are the notes that we copied onto your periodic table yesterday. We said that metals have a positive charge, lose electrons, and are on the left side, and we should add or below the bold zigzag line here. Hydrogen can act as a metal. In other words, it can be a +1 or it can act as a non-metal, a -1. It is actually a non-metal. Okay? Non-metals are anions. They are to the right-hand side of the bold zigzag line. They have a negative charge because they gain electrons. They are over here, ladies and gentlemen. The noble gases are group 18, and they do not react. Then what we did is we went through and we said, all right, what is the charge on everything in group number 1 minus hydrogen, because hydrogen is special. Lithium, sodium, potassium, rubidium, cesium, and francium are all a +1. So below that group, we wrote a +1. Beryllium, magnesium, calcium, strontium, barium, and radium are all a +2. We come to group 13. Aluminum, gallium, indium, thallium, and niobium are all a +3. Okay? Now, we will not write compounds with some of these elements. We don't write many with thallium. We won't use niobium or fluorovium. We just won't use those. Those are man-made elements, okay? When we got to group 14, ladies and gentlemen, this was the +4, -4. Now remember, the reason it was +4 and -4 is because there are what are called 4 valence electrons. 4 electrons in the outermost shell. And it takes 8 electrons to fill that outermost shell. So when you have 4 electrons and 8 fills it, you have 2 choices. You can either gain 4 electrons or you can lose 4 electrons. Which one is easier? It is about the same. So at this point, ladies and gentlemen, we said that the ones that are down below, germanium, tin, lead, and whatever the heck that is, are a +4. Why? Because they are the metals. Metals are always positive. But silicon and carbon, which are nonmetals at the top, those would be a -4 if they are going to gain electrons. From there, ladies and gentlemen, we switched over because now we have 5 valence electrons, and it is much easier to gain 3 than it is to lose 5. So, nitrogen, phosphorus, arsenic are all a -3 because they will gain 3 electrons. Oxygen, sulfur, selenium, tellurium are all a -2 because they will gain 2 electrons. Fluorine, chlorine, bromine, iodine, astatine are all -1 because they only need to gain 1 electron to fill their outer shell and become stable. Declan.
Does that mean like the first row and then with like the +1 and then the row with like the -1 charge, they would combine?
First of all, rows do not have charges. Groups or columns going up and down have charges.
The family with 1 charge, +1 charge, and the family with 1 negative charge, wouldn't they combine really well?
Yes, they're the most reactive families. They combine really well. Yes, yes. And then there are the noble gases. Helium, neon, argon, krypton, xenon, radon, and oxygen. Those do not combine with anything, ladies and gentlemen. They have a charge of 0 because they are already stable. They have a full outer energy level. They do not need to gain or lose any electrons. Questions? Now, there are some that are an exception, ladies and gentlemen. Boron cannot be a +3. Why? Because it's a nonmetal. Nonmetals will never be positive ions. So if we had to find out what the charge of boron was, ladies and gentlemen, we would have to say it would be a -5. Now, I don't think I give you any compounds where boron acts as a nonmetal as a -5, but we could. Okay? We could, because we're following a pattern. The same way, ladies and gentlemen, antimony and bismuth are not a -3. They cannot be a -3 because they are metals, and metals don't ever gain electrons. Metals always lose them. So the only thing these two atoms can do is lose their 5 valence electrons and become a +5. Okay? Again, I will not give you compounds with those in there. Polonium cannot be a -2 because it's a metal. It would instead, if we had to predict it, we could say it could act as a +6. Why? These are +4. These would be +5. These would have to be +6. We're following a pattern here. Questions? Now, we have ignored these, ladies and gentlemen. We have ignored these because these do some weird things. Okay? What I mean by weird things is iron, for example. Iron can have a charge of +2 or +3. Not because we want it to, because that is the way it combines with other things. Okay? Please understand this. We didn't set this up and say, well, this has to be a +2 because it's here. No, after studying compounds and finding out the ratio of how much of this reacts with how much of that, we figured out that the charge of that group has to be a +2 because of the way that it always reacts in a compound. So again, when we look at iron compounds, we found that there were 2 ways iron reacts. Iron either reacts as a +3 or a +2. Meaning, ladies and gentlemen, I'm never going to expect you to know which iron we are using, +3 or +2. There is a way when we name it that you can tell, and I will expect you to know what it is by the name. Okay? But I do not expect you to be able to go into here and go, well, what's the charge on cobalt? No, you wouldn't know that it's either a +1 or a +2. I would have to give that to you somehow, and I will do that. We did, however, say zinc, very common in compounds, is always a +2 ion. I asked you to write it by the zinc. I also asked you to write by silver that it is a +1 ion because that is used in many compounds as well. Okay? So these are the exceptions in here. These are things that could sometimes have more than one charge. By the way, another way of saying charge is to call it an oxidation state. What that means is the apparent charge that it has by what it's combined with. Okay? And that's what we talk about when we talk about iron. Iron has an apparent charge because when it's combined, it either acts as a +2 or a +3. Okay? Now, these can get a little bit confusing because something like chromium, ladies and gentlemen, chromium could be a +1, a +2, a +3, a +5, or a +7. Not because we want it to be, but that's the way it reacts with different compounds. Again, I'm not expecting you to memorize that. We'll show you how to handle it when we get to it. Okay? But what it also means, ladies and gentlemen, is there are some exceptions that are in here. Why? Because these are larger atoms and the electrons can do some crazy things. There's a couple of exceptions right here too. What should tin and lead normally be? What would their charges normally be based on where they are at? +4, and that is 100% true. However, they can also act like a +2 or a +4. For both tin and lead, they can act like a +2 or a +4, ladies and gentlemen. Okay? Both tin and lead, because of the family they're in, could be a +4, but they also at times will act like a +2, just so that you are aware of that. Questions? Now, here's what I will tell you, ladies and gentlemen. What we are about to do is start writing compounds. If you can't tell me the charge of this, based on where it's at on the periodic table, you cannot write a compound for it. So I am hoping that you understand what we have just gone through. And if you have questions, you are now going to raise your hand and ask. Because if not, ladies and gentlemen, what we are about to start doing, you will struggle with immensely. So questions? Ben.
So everything between the 2 and 3 is just a 2 for positive charge?
Between 2 and 3.
Yeah.
I
So
don't. This 2
Mhm.
and this 3
No, and then the positive 3 over there.
over here?
Mhm.
No. These have various charges. These I have to give you another way. I'll show you how we're going to do that. Okay? The only 2 that we are sure of are zinc is always a +2 and silver is always a +1. By the way, we will not write any compounds with gold. We just won't do it. We won't write compounds with osmosium or iridium. We just won't do it. Okay? Doesn't mean it couldn't be done. Just means we won't do it because there are not very many common compounds with those things in it. We'll stick to the more common ones for you. Okay? Point being, though, if I give you a metal with a charge and I give you a non-metal with a charge, you should be able to write a compound for it. Some I expect you to know the charges. If it's in group 1, I expect you to know that it's a +1. If it's in group 2, I expect you to know it's a +2. Even if it's in group 13, a metal down here, those are all +3. No exceptions to those. None. Okay? But we get into group 14, germanium is a +4. Tin and lead are +4s, but they could also act as a +2. We'll show you how to distinguish when they're doing each one in a little bit. Okay? Now the non-metals, they're easy. Oxygen, always a -2. Fluorine, always a -1. Nitrogen, always a -3. No questions about these. None. And we can't put a noble gas in. Why? They don't need any electrons. They're not going to gain any. They're not going to lose any. They don't do anything with a compound. So they can never be involved in a compound. Now, as I tell you that, okay, later on you get into some higher level chemistry. There's probably some exceptions there. None that we're going to do in this class, though. Questions? Okay. I gave you a grade report, ladies and gentlemen. I'm sorry I forgot to give it to you yesterday. The one thing I want to point out is your current grade is not the final grade at the top. The final grade at the top was the grade when I put it on the report cards last week, Friday. That was the grade that appeared on your report card. We then took the test Friday during the day. Your grade changed after the test. So keep that in mind, ladies and gentlemen. Your actual grade is the in-progress grade right now. That is where you are at for the class right now, just so you know. Okay? Down below, if you are missing anything as far as quizzes, labs, or tests, which nobody in here is, otherwise I would have you be doing them right now. You're not missing any quizzes or tests, at least. If you're missing labs, you got to get them done and get them turned in to me. Are there any questions on that? I hope to be able to give you your tests back tomorrow, Thursday at the latest, ladies and gentlemen. I'm still waiting on some people to take it. All right, so let's go back to this, ladies and gentlemen. All right. So this is again where these charges came from. This I gave you yesterday. The charges are based on the valence electrons and what is easiest for the atom to do. When an atom has one valence electron, it is easier to lose that one than it is to gain 7. That's why all of those alkali metals have a +1 charge. Now, +2, 2 valence electrons, because again, it's easier to lose those 2 electrons than it is to gain 6 more to become stable in the alkaline earth metals. And that is how these charges relate to the valence electrons. Now, what was unique about 4? Why?
Because there's 8, so it's the perfect half.
It's a perfect half, which is why it can be a +4 or a -4, correct? Good. Now explain why hydrogen can be a +1 or a -1.
Because it only needs 2 to fill its down shelf.
And it's half full as well. So hydrogen, which is up here, ladies and gentlemen, we said it can act like a +1 or a -1. Why? Because it is half filled as well. Because the first level only needs 2 electrons. So it is half full, so it is just as easy for hydrogen to lose an electron as it is to gain an electron. That is why hydrogen is unique. It can sometimes act as a positive ion and sometimes as a negative ion. Questions? All right. So let's talk about making compounds here, ladies and gentlemen. We are going to begin with what is called a binary ionic compound. What does binary mean? 2. Ionic means it's between 2 different ions. What kind of ions will attract each other? Opposite. So we have to have one ion that is a positive, one ion that is a negative. What gives us positive ions? What gives us positive ions? What kind of element? Metals. What kind of elements give us negative ions? So a binary ionic compound is a compound between a metal and a nonmetal. Okay? A compound between a metal and a nonmetal. It is the simplest compound there is, ladies and gentlemen. 2 different elements, a metal and a nonmetal, are bonded by gaining or losing electrons. Now, it doesn't work yet. Did you have a pass from somewhere?
Yeah, attendance.
Okay. Go ahead and refresh it and end it out then. Thank you, sir.
Mr. Grant,
Yes, go ahead. I'm listening.
the presented notes don't have anything in them.
The presented notes don't have anything in it. I will have to look at that later then. So stay with me on these for now. Okay? All right. So all atoms want to become what? Stable. How do they become stable? No.
By filling its outer valence.
By filling its outer shell. But when you fill your outer shell, you will gain or lose electrons. If you gain electrons, what charge do you have? Negative. If you lose electrons, what charge do you have? And then what happens when you have a positive and a negative near one another? Well, they are attracted to each other. They cannot get away from each other. So the compound happens because 2 atoms are trying to become stable. 2 atoms are trying to become stable, but by becoming stable, they become oppositely charged. And then they are attracted to one another, ladies and gentlemen. They are attracted to one another. Now, you are going to have to do 2 things, ladies and gentlemen. You are going to have to write a formula, and you are going to have to name a compound. If I give you a name, I expect you to write a formula. If I give you a formula, I expect you to name it. So let's talk about writing formulas, ladies and gentlemen. You write the symbol of the metal with the charge first. Now, we could say metal or we could say cation. Because we are in binary ionic compounds and there are only 2 elements that are combining, you will probably hear me refer to metal more often. When we get into ternary ionic compounds, then I will say anion and cation because it could be an individual metal or it could be a group of atoms acting as a positive ion. Okay? A lot of stuff I know. We will get there. So you write the symbol of the metal with its charge. You then write the symbol of the nonmetal with its charge. So for example, magnesium plus 2F minus 1. These are superscripts, ladies and gentlemen. They are written after the number or after the symbol because they indicate the charge. By the way, I don't care. Some people do +2, others do 2+. It means the same thing. That is still the charge. Okay? You then do what is called a crisscross method, ladies and gentlemen. The reason we do a crisscross method is every compound that we create has to have a total charge of 0. 0. And the crisscross method never fails. Never. No exceptions to that. It never fails to get you a compound that has a total charge of 0. It will work every single time. Without fail.
What is the?
I'm going to show you. I'm going to show you. Okay? What the crisscross method is we are going to crisscross the superscripts that are there and make them into subscripts for the atoms. So, for example, we have magnesium +2, and we have fluorine -1. We are going to take these superscripts and we are going to crisscross them and make them into subscripts. Why? It will guarantee us a compound that has a total charge of 0. Guaranteed every single time. Okay? When we do this, though, one of the important things is we drop the signs. Charges can be positive or negative. Subscripts cannot. Subscripts have to be a positive amount. Okay? So that means that we go Mg1, F2. Okay? Now, we never write the number 1. Why? Well, by saying there is Mg here, you're saying there's at least one of them. We don't like to be repetitive, so we never write the number 1. Okay? Now, the only place that the crisscross method can let you down, ladies and gentlemen, the only thing it doesn't do is it doesn't put your subscripts into lowest terms. It doesn't reduce them. And because there are multiple ways of combining two atoms so that their total charge is 0, in an ionic compound, we always have to reduce our compounds into what we call lowest terms. Okay? We have to reduce them into what we call lowest terms. This one is already in lowest terms. How do I know? Because there was a 1 by the Mg. You cannot reduce 1s. They are already in lowest terms. What I'm talking about is if you have a 2 and a 2. If you have 3 and 3. If you have 2 and 4. 3 and 6. 2 and 6. Those could be reduced. We will show you those as we go on in a few minutes. Questions on how to write a formula? Okay, writing names. You write the name of the metal, whatever it is. Whatever the metal is, you write the name of it. You then write the name of the non-metal, just as it is off of the periodic table. And now, to indicate that it is a compound, to indicate that it is combined with the other element, you change the ending of the non-metal to IDE. That is the entire naming process for a binary ionic compound, ladies and gentlemen. You write the name of the metal, you write the name of the non-metal, you change the ending to IDE. That's it. Okay? Now, you do not worry about the subscripts. If there's a 2 down there, we don't worry about it. There's only one way to write these compounds. So you don't have to worry about, is it a di, is it a tri, is it no. It's a different naming system. So carbon dioxide, not a compound in this naming system. Okay? We don't worry about the numbers down below, about the subscripts. Write the name of the metal, write the name of the non-metal, change the ending to IDE. Okay? Now, just so you know, ladies and gentlemen, fluorine becomes fluoride. Chlorine becomes chloride. Bromine becomes bromine. Iodine becomes iodide. Astatine becomes astatine. Now it gets a little bit more complicated. Oxygen becomes what? Oxide. We go back far enough to where it sounds good. What I mean by that is we wouldn't do oxygen. Just doesn't sound very good. So we go all the way back to the X, we make it oxide. Sulfur becomes sulfide. Drop the UR, put an IDE on it. Selenium becomes selenide. Selenide. Nitrogen. Nitride. Get rid of the OGN. Go all the way back to the R. Nitride. Phosphorus. Nope. Drop the OR. Phosphide. All the way back to the H. Arsenic. Little more. Arsenide. Okay, and again, you will learn these. We will become better at them. Carbon. Carbide. Silicon. Silicide. Okay. Boron. Boride. How about hydrogen? Hydride. Hydride. By the way, that's all of them, right? I mean, that's all of the nonmetals, basically, correct? What would neon become? Nothing, because it never goes into a compound. We're not going to change the last name of it. Okay? By the way, here's the other reason neon could never go into a compound. We do the crisscross method to get a total charge of what? 0. If we have a positive number and 0, what can we multiply the 0 by to make it cancel out a positive charge?
0.
Nothing. There's no way to make it cancel out a positive charge. The only way you can cancel out a positive charge is with a negative charge. Cannot be done. That's another reason that the noble gases will never get involved in a compound. Questions? Okay, good. Here we go. So, we're writing a formula. Na plus 1, Cl minus 1. Okay? We do the crisscross method, ladies and gentlemen. The total charge on a compound must be 0. This one comes down here. This one goes down there. Now, you may be sitting there going, Mr. Brand, why are we doing this when it's a 1 and a 1? Because what is positive 1 and negative 1? 0. I'm just showing you a method that never fails you. Showing you a method that never fails you. If you can recognize that these two charges cancel and write the formula without doing the crisscross, I don't care. All I care about is when you're done, this is what your formula better look like, NaCl. We crisscross these. Why do we get rid of them? Because they're ones, and we never write ones. You will never see a formula written with a 1 in it. Never. Questions? All right, here we got magnesium plus 2, nitrogen minus 3. Okay? Total charge on a compound must always be 0. So what number am I going to put by the magnesium? What? I'm going to put a 3 by it. What number am I going to put by the nitrogen? 2. Okay? So my formula is going to be Mg3N2. Questions? By the way, to make the subscripts, Control and the comma key on your keyboard will put you into a subscript mode, where what you type then after will be a subscript, ladies and gentlemen. It was already in it? Sorry, if I left it in there, you're going to have to take it out. So you could highlight, you could hit Control and the comma key to get into and out of it. Sorry, I sometimes do that, ladies and gentlemen. Okay? What's that? What's the matter, KP?
I was kidding.
No, I probably deserved it, so. Okay? All right. Here's what I want to show you, though, ladies and gentlemen. All right. This compound right here, this one, says we have Mg plus 2, Mg plus 2, and Mg plus 2, combining with nitrogen minus 3 and nitrogen minus 3. That is what this would look like. 3 Mgs, 2 nitrogens, right? Okay. These 3 Mgs, they are all +2, correct? How many of them are there? 3. That means that the total positive charge is +6, correct? How many nitrogens are there? 2 of them. And what is the charge of each one? Which means that total charge is? Total is 0. Total is 0. Now, why does the total need to be 0? Well, it needs to be 0 because nitrogen needs to gain how many electrons to become stable? To become a -3, how many does it need to gain?
5.
It has 5. How many does it need to gain?
3.
3. The problem is this magnesium can only give how many? 2. So it gives 2. This is stable, but this isn't. Right? So another magnesium comes along and says, okay, I'll donate an electron. It gives 1 to this nitrogen. Now this nitrogen becomes stable. 2 electrons from here, 1 from here, right? But is this stable? No. So now you need another nitrogen. It gives that 1 electron to this nitrogen. This is now stable. This is now stable. This is now stable, but this isn't. Still needs 2 more electrons. We need to get it so that every atom in the compound, every single atom in the compound has a full valence shell. The only way we do that is if the total charge on the compound is 0. That is the only way that happens, is if the total charge on the compound is 0. And that's why we go through this, ladies and gentlemen. Questions? All right. So now, potassium, +1. Why is potassium a +1? Why? Why is potassium a +1? Because it's in the first family or the first group. Everything in the first family or the first group is a +1. Oxygen is a -2. Why? It's in the group that is a -2. That's where I'm getting these from. In case you were wondering, where's he getting this +1? Where's he getting the -2 from? Potassium, +1. Oxygen, -2. That is the way that they will become stable. That is the way that they will fill their valence shell. So what is the compound going to look like here when we are done? K2O. K2O. We are going to crisscross this 2 down to here, the 1 down to there. Remember, we drop signs. You can't have negative numbers down here. This is representing the amount of potassiums. It can't be a negative number. And we never write the number 1. Questions? Anyone need more time? I'm sorry if I left those in subscript mode for you. All right. Lead, +4. Sulfur, -2. Now, lead, I would have to tell you it's a +4, ladies and gentlemen. Okay? It is in the +4 family, but remember, I said it could also be a what? +2. I have to distinguish that for you right now, ladies and gentlemen. I have to tell you which one it is. When we do the crisscross method, ladies and gentlemen, what do we end up with? What is our formula? When we do the crisscross method, what would our formula be?
PB2S4.
PB2S4. Absolutely correct. Total charge of 0. What's wrong with it, though?
You can simplify it down to 1, 2.
We can simplify it down. That is the one place that the crisscross method lets us down. It always gets us a charge of 0. But when we have a 2 and a 4 here. These can be reduced. They can be reduced. They can be reduced by 2 each, bringing it down to PBS2. Bringing it down to PBS2. And that's the one time where we have to be careful with our crisscross method. If we can reduce our subscripts, we have to. Questions?
No.
Questions? All right. So what's the charge for aluminum, ladies and gentlemen? Based on the periodic table, Kiana, what's the charge of aluminum? Positive 3. What's the charge on bromine, Evan? -1. So now that we have the charges in there, ladies and gentlemen, what would the compound look like when we are done? After we do the crisscross method, what does our compound look like? I'm sorry? Let me get that. What is it? AlBr3. AlBr3. Questions? Yes, no, maybe so. You have a number of steps to go through when you write formulas, but you are repeating the same steps over and over again. Write the metal, put its charge. Write the nonmetal, put its charge. Crisscross method. To get the numbers that go down here. Get rid of the plus and the minus sign. Get rid of the number 1. And then reduce if possible. Again, remember, the only things you can reduce are like 2 and 2, 2 and 4, 2 and 6, 3 and 6, 3 and 3. Okay? Only certain combinations. We're never going to have a charge of like 15 and 13. We just don't get to that kind of charge. Okay? We just don't get to that kind of charge. Questions? All right. So now let's write names. Okay? Dante, what is Al?
Aluminum.
What is Cl?
Chlorine.
What does that become?
Aluminum chloride.
Boom, that's it. There's your whole naming system, ladies and gentlemen. Write the name of the metal, aluminum. Write the name of the nonmetal, chlorine. Change the ending to IDE. That is the entire naming system. Ben, what is Zn? Number 30 on your periodic table?
Number 30.
Yes, number 30 on your periodic table.
Zinc.
Thank you.
Zinc.
What is O, Anthony?
Oxygen.
Okay, sorry, I was looking at Anthony Bias, but that's fine. So Anthony Bias, what does oxygen become when it's in a compound? What does it have to end in? What did the one above it have to end in? Nope, it has to change its name. Write the name of the metal. Write the name of the nonmetal. Change the ending to IDE. So what does oxygen become? Close. Close. Oxide. Okay? Oxide. Zinc oxide. Okay? That is the compound, ladies and gentlemen. Zinc oxide. Okay? We change the ending of the oxygen to IDE. Zinc oxide. What is Ra? What is Ra, Jasmine? Radium. What is C? Maya. What is the element C? Which becomes, remember, we need to change it to an IDE ending. What would that become?
I don't know.
Okay, get rid of the ON. Drop the ON in carbon and make it an IDE ending. Very good. That is the name of that one, ladies and gentlemen. Radium carbide. Again, write the name of the metal. Aluminum, zinc, radium. Write the name of the nonmetal. Chlorine, oxygen, carbon. Change the ending to IDE. Chlorine becomes chloride. Oxygen becomes oxide. Carbon becomes carbide. Questions? Ga2S3. Ga2S3. What do you got, JD? Gallium sulfide. Ca3P. Ca3P. What do you got, Michaela? What's that? I'm sorry, I can't. What?
I don't know how to pronounce.
Okay, well, what's the start? What's Ca?
That's what I don't know how to pronounce.
Calcium. Calcium.
It's written weird on it.
Okay, sorry.
Calcium. Phosphide?
Okay, close. We go back a little further. Drop the OR. Phosphide. And you'll get to know these as you go through and name compounds. Phosphide. Calcium phosphide. All right. BaI2, Isaiah.
What is that? Barium?
BA, yeah, it's number 56 on your periodic table.
Barium.
Yep.
Iodine.
Now remember, change the ending to what?
Iodine.
He said that.
Ionide?
Yeah.
Okay. Iodide, sorry.
Oh.
Iodide.
You died?
Drop the INE and change it to ID. Iodide. Okay?
It's fine.
Barium iodide. Okay? Questions?
Oh, you're not up.
All right. So, you guys, tin 4 sulfide. Write a formula for it. You got the name of ZNO. Okay? ZNO. By the way, the 4 means that tin will have a +4 charge. Okay? You guys, magnesium oxide, write a formula for it. You guys have the name SrCl2. Anthony, you've got calcium phosphide, a formula for it. You guys have the name for Ge3P4. Ladies in the back, you've got a formula for aluminum chloride. You got, actually, you can work with Anthony on his. You can work with Anthony on his. You guys have KNO3, or K3N. I'll get it right yet. Ladies, you have sodium iodide. I want a formula for it. Michaela, work with Morgan on a name for GABR3. Okay? Let's go. Let's go. Let's go. So if you have formulas, remember, we're doing this. Write the symbol with the charge for each of those things. Do the crisscross and get me a formula. If you need scratch paper, ladies and gentlemen, there is some up here that you can come up and grab.
Lithium sodium oxide.
This is not the, there's tricks and things, but it's not the most difficult thing. Yes, the GE3P4. Yes, sir. Okay, so what's the GE3P4?
Oh, yeah, for games you don't want.
GE.
Well, I don't know.
Finishers?
Yeah, I gotta see.
Okay, fill it out in your thing. Now, if you need me to take a look. How we doing?
Yeah, but it's, write down.
So, I would take it on a sheet of paper, I would put aluminum, and I would put it
So
sharp.
what do you do after this?
Then I would take
Okay, so since Tim has a charger plus 4 and
Right, it's
some sorts like that, so technically right now, what you have,
I don't know how much. We'd have to do that. Okay,
okay, so what you have right now is technically this.
Oh,
how we doing,
Technically
questions?
right now have an S and S minus 2, right?
Morgan, how we doing? Maya, here you go.
So once you put it down to the bottom, it just becomes 2. Okay, and so then technically this becomes 2 and 4, and that's kind of so having 2 over 4,
We're about
that's kind of like that right now. So the 2 cancels out, it just becomes S and S. So like that's the charges, right? Like you have a lot of charges for both of them, but you still have to do the cross multiply or whatever, the cross canceling out.
The crisscross,
Yeah, the crisscross.
okay? Remember, it's crisscross. Some people do the, I'm gonna drop it down method, which is I'm gonna take the numbers from up above and move them down, but that doesn't work because that doesn't get you a charge of 0. Alright, GABR3. Give me the name of that. Gallium bromide. Gallium bromide. Okay? Gallium bromide. How about the formula for sodium iodide? Okay, what's the charge on sodium? What's the charge on iodine? So what would be the formula? If they're both ones, what would be the formula? NaI. There you go. That's it. That's it. Okay? NaI. All right, I guess I'm going to do this the hard way, ladies and gentlemen. Aluminum chloride. What was the formula for aluminum chloride? Michaela, Rose, what'd you guys get? AlCl3. Perfect. Aluminum is a +3. Chlorine is a -1. When we crisscross them, AlCl3. Calcium phosphide. Who had calcium phosphide? Go ahead, Anthony. Ca3P2. Perfect. Who had magnesium oxide? What do you got? MgO. Now here you would have a 2 and a 2. This is a +2. This is a -2. You then reduce them. That is MgO. Good. And how about tin 4 sulfide? KP, Isaiah? SNS2. Perfect. By the way, you remember when I said there had to be a way of knowing what the charge was on something like tin because it could be a +2 or a +4? What is IV?
4.
In what? Yeah, you guys are going to get a crash course in Roman numerals this unit. Because you have to know them to be able to write this formula. Okay? So that is the way they will distinguish something that you cannot tell its charge by looking at the periodic table. They will use a Roman numeral in it. All right, GABR3. Again, what was that again, Michaela? I'm sorry.
Gallium bromide.
Gallium bromide. K3N, what was that one?
Potassium nitride.
Potassium nitride. Potassium nitride. IDE ending. GE3P4. Germanium what?
Figured it out.
Germanium phosphide. SrCl2. You're close. That's good enough. What else?
Fluoride.
Strontium chloride. Guys, I am not expecting you to pronounce these really well. Some people would tell me I don't pronounce them really well. That's okay. Okay, just give me your best effort. What is the last one here? Keanu. Zinc oxide. Zinc oxide. Okay? Yes.
If like on a test it asks us for like the name of an element, like you give us like the symbol and then you want us to give like the name, or like we have to do that in a problem.
Yep.
If we can't read it off of here, like because I can't, like some of these I can't read.
Okay.
The small font for the name is too.
I will help you with spelling on things like that. Okay? If you can't read something on there and you're not sure, and again, maybe you're close enough to see it here or whatever or not, call me over and I will help you with that. I will help you with that. Okay? Now, don't say, Mr. Brand, where's the element Ca on, or how do I write the formula for that? But I will tell you how to, the name or the spelling for it. Okay? The name or the spelling for it. Questions?
We better be talking about ternary ionic compounds, or else I might cry.
We better be talking about what?
Ternary ionic compounds.
Ternary ionic compounds. That's another day. Relax. Okay? That's another day. Relax. All right, ladies and gentlemen, go into your Google Classroom and there is a worksheet there. The worksheet is binary ionic compounds, ladies and gentlemen. My suggestion would be to get with a partner and start working on this. But if you want to work on this on your own, you are welcome to. By the way, control, not plus, but in addition to the comma key, will put you in a subscript mode always. That is how you type the numbers down below. Control and the period key will put you into a superscript mode if you need to put for example, a charge with something. Okay? Now, here's what I would tell you, ladies and gentlemen. On this part here where you are writing names, you can probably do that fairly easily. But when it comes time to write a formula, ladies and gentlemen, you may want to grab a piece of scratch paper so that you can do the symbol with the charge, and do the crisscross method before you try to type the answer into here. Again, you can work on this alone. You can work on this with the person sitting next to you. You can go get a group of 4 or 5 people together at a table. Work on it. I don't care. But let's go. Get some practice done, ladies and gentlemen, because this is what's on the quiz on Thursday. Anthony, I'm sorry. As soon as you went to talk, everybody else did what?
I saw it on Instagram and I was like, oh, that's for sure how I'm gonna remember that.
Ever since I started this class, I keep getting like chemistry jokes on my feet.
That's how I
How are you gonna do that?
because it was like, you know what that meme and it's like the charge.
You have to give it a little time. How dead is your computer? Try a different port in it too, because I know that one works.
But
one of mine doesn't work.
Okay.
Only have
I will go get you another one, but I know that charging thing works. But I will get you a different one and see if that works.
Yeah, go over a year and I spent something in the sun.
Hopefully that'll work for you. If not, I don't have another one. I'm sorry.